So we've been, up until now, we've been doing all of our development on the front end, right? Stuff that happens in the browser of your users, right? All of the JavaScript we've been writing, all of the HTML, all of the CSS has existed solely on our computer for us to like play with and fiddle around with, but it's all front end development. What Node gives us is the ability to run JavaScript on the server and handle requests, okay? So what is Node.js? Just as a short history here, right? So some people in the late thousands, early teens, loved working in JavaScript and said, hey, it would be really cool if we could write JavaScript on the front end and write JavaScript on the back end on our server. Up until then, JavaScript was purely a front-end programming language. So what they did was they took Google Chrome, which is an open source browser project from Google, and they said, hey, let's take the JavaScript interpreter, the JavaScript engine that runs behind the scenes, and instead of running this whole browser, we're just going to run the JavaScript engine on a server as a program. And so what they ended up with was a very nice, tidy, little compact way to run JavaScript on the server for the first time. Now, part of the reason you guys are taking this class is that there are, tens of thousands, if not hundreds of thousands of software engineers who focus on web development. What this enabled was that for the first time, you could write the same code on the front end and use the same programming language on the back end. Traditionally, a full stack web developer, you'd have to know PHP or Ruby or Python or C++ in the olden days, ASP.NET. But now we can write JavaScript exclusively, right? So that it makes hiring and training software engineers a little bit easier. You can build all the same kind of tools, and you don't have to worry so much about needing to know a bunch of different programming languages. So just to give you a quick example of what Node.js is, here I'll use Nano. I'm going to make a file on my computer, and I'm going to come in here and say console.log hello world, right? And I'll maybe do some math in here, so I'll say let age equals 37. And, we can write a function that is like do something console.log hi from the function. And then we could say, console.log your age is, age, and then we can call our function do something, right? So just regular JavaScript code, all the stuff we've been doing on the back end. What Node.js lets us do is that when we run the file, right, I've got an index.js file in here. When I run this with the node command, and I call index.js, it's going to run that on the computer as if I was, writing code in the browser as like a developer console or something. Okay, so all of the JavaScript we've been learning up until now, arrays, objects, functions, classes, all of that is available to us that we can run with a program called Node that will run all of our code for us on our server. Any questions about that part? Okay. Next up, this is going to be interactive. We need everyone to at least get Node installed in their computer. So I'm going to walk through this for the Windows folks. The Mac folks will have slightly different steps, but if it doesn't work, let me know and we'll share your screen. We got to get everybody to get this installed. So we're going to go to, we can just type Node.js into Google. The top link, it's nodejs.org. It's going to take you to a page that looks like this. Okay? And I want to point out something here because Node uses this kind of language a lot. They give you two choices here. LTS stands for long-term support. LTS stands for long-term support. It means that if you run this version, 14.18.1, that is a stable version that Node has worked on. They said it's safe to deploy this. This version will run for a couple of years. No big deal. 17.01, you can see there are 3 entire versions ahead, is the current, right? So it's got new features in JavaScript in Node that maybe this one doesn't have. So if you want to work on the cutting edge, you want to experiment with new features, you can run this version. But what we're going to do here is we're going to download and install the LTS version. Okay. And for you Mac folks, you might actually see different stuff on this page. So does it have a download option or does it take you to a page or something? I think they probably want you to install it with Homebrew.
It looks exactly the same. It just says download for Mac OS.
Okay.
Yeah.
Good. So when you get it, you're going to get the file. It's going to pull up some kind of installer for you. I already have it installed, so I'm going to skip all these steps, but I'm just going to walk you through. You accept the license agreement. It's going to ask you where you want to install it to. The default location is fine. All these options, right? The Node.js runtime, that's what actually runs the code for us. NPM package manager, we're going to go over that today. That's where we install modules and do kind of harness the power of open source to let us write better programs. Documentation shortcuts, that's extremely useful for us. And we want to make sure that we add it to the path so that we can run it from our command line. So all of those things are selected, right? We're going to click next again. So some NPM modules need to be compiled with C and C++. If you want to be able to install some tools need to be installed. You can mark this as yes, or I'm going to say no in this case. I've never needed those tools, but just be aware that if you ever run into an issue with a Node module, it might want you to do that. You can always come back to this page, Node.js, just run the installer again and get those things installed if you want. It's completely up to you. And then it's going to run and install. Pretty simple to get it going. Go ahead, Kareef.
While we're waiting on that, well, no, I'll wait.
No, go ahead.
No, I was going to ask a question about an install on the Mac while you were waiting on that.
Okay.
It was telling me that I need to connect the user, the local bin
Yeah, that's
to your Mac.
Yep. Does it tell you how to do it?
No.
Share your screen. Let's take a look. Okay. Okay. Yeah. It's saying make sure user local bin is in your path. User local bin is already in your path by default, so you should be fine.
Oh, okay.
But if you, for whatever reason, had installed it and if you were already in there fiddling around with your path, then it could have possibly broken.
Roger. Thank you.
And all the path variable does in your operating system is that when you run a command, like I'm inside of here, and this is going to be true on Mac as well, Linux, Unix, FreeBSD, all of the different operating systems have this concept of a path. And so what path is a variable of all the places to look for programs, right? When we run things like ls, right? It's not actually doing anything in the operating system. It's running a program called ls that exists in one of these folders. So it's just a search path to look for these file names. So for your example, it's saying, we just installed Node.js into user local bin. So when you type node in here, it's running node from user local bin. So it needs to be in that path string. All right. Does everyone have it installed? We're all good? All right. Just a quick run through of what if you're inside of your terminal, right, you should be able to type node in here. We're going to put node -- version, right? It should say the version that we just installed, 14.8.1, or if you picked the current path, it would say 17.0.1. Okay. So everyone, when you type node in your console with version, it tells you the version. Selena says yes. Josh, Grief.
Are you getting it, Kareef? I'm not getting it either. But I mean, when I just type in no, it will tell.
Yeah, I can't even find mine in the apps.
You don't run it as an app. You run it from your terminal.
Oh.
Yeah. So pull up in your terminal window, and type node -- version. For the rest of this course, I mean, this is one of the reasons why we teach this kind of in week 1. you're going to be very heavily involved in your console, in your terminal, all the time, because we're going to be running apps from here. So, Josh, yours says cannot find?
Well, if I just type in Node, it tells me what version I'm running and everything. But when I type in Node -- version, it doesn't come up with anything. But I am, when I type just Node in, it
What
says
version does it tell you it's running?
version 14.18.1.
Okay. So the version for Mac probably just doesn't have this -- flag.
Yeah.
So, I mean, there's probably something in node -- help or something that will tell you. Maybe try -v with just a single dash. I don't know. Anyway. All right. Crave, were you able to get this running from your terminal? Great. So one thing I want to show off real quick is you notice when I was playing with the index.js file, right? Index.js. I was running it with node and then the name of the file that I want to run. It's going to run that code until it's done and display it to the console, and it takes me right back to a terminal where I can type. The other way that we can interact with node is called the REPL. REPL is REPL, and it stands for read, evaluate, print, and loop. So when we run node by itself, we are put in the REPL of node, right? So in here, it's just like being in a developer console. I can type in like let name equals Eric. I can type in console.log name, and it will do all of the things. It's giving me a line-by-line interpreter where I can play with and test node code as if I was in my browser's developer toolbar. Okay, so the REPL here is extremely useful, similarly to how our developer console is useful, in that we can go in there, test some code, see what it's doing. We can explore objects, right? If we say console, let's make an object here. I'm going to say let obj equals name Eric. Eric. I'm going to put comma age 37, right? So object is as an object, and if we just print it out like this, it gives us kind of the same sort of display that we get in our browser. It's obviously not as nice, but we can look at our objects and see what values are in here. So this is extremely useful for interactively debugging.
Or what? I'm tired.
Did you have a question, Olivia?
Oh, no, sorry.
Okay. So this is the REPL. To exit the REPL, we have to type .exit. And if we just run node again, we're back. Like every time we run node as a REPL, it's like opening a brand new page where we get a new developer console. All the variables we had defined in the previous session are gone. Right? They only exist while we're in here the first time. So if I say let name equals Eric, right? I can type name and see that it has the string value of Eric in here. Okay, and then if I leave and I come back and I type Eric, it's going to tell us Eric is undefined. Okay. Go ahead.
This is for Karif. I didn't realize that when I typed in node, it took me right to that console that we just learned. So when I was typing node -- version, I was already with like.
Oh, you were inside here. Yep.
So once I got outside of it and then typed in the node -- version, it worked.
Oh, great.
Yeah, that's what happened to me too.
Yep.
I typed .exit and typed node again, and it brought me back. So everything.
Yeah, generally I don't often spend a lot of time in the REPL for node. I find it much easier for my mental model to write code in a code editor, and then if I need to, I'll test it inside the REPL. But for the most part, I just try to write good code, and all the same tools that apply in JavaScript on the front end, right? If I'm going to console.log things to see what the values are, just so I can watch and see what's happening. Any questions?
Now,
Go ahead.
Now, I had a question. Is it possible to run Node in VS Code since it's on our laptops?
Yeah, perfect. We'll open. Right. So we're in here, right? If I pull up into terminal, right? I'm inside this console. It's the same type of terminal that we're in here, right? So I can say Node, and I'm in here running. And when we start writing servers later this week or early next week, we'll run the server in here so that while we're writing our code up here, that we can watch what the output of that server is. Okay, good question. All right. And then the big performance reason, right? The reason this is super amazing, which we're going to go into here in a few minutes, is Node by default, right, is just the JavaScript language, right? We're in here, we're able to write numbers, we're able to write arrays, we're able to, create for loops and things like that, right? Let's show that off, right? So I'll say let my R equals, 15, 25, 37, 42, right? So we have an array here. We can do all of the things that we do in generic JavaScript inside of Node. But what makes Node super powerful is that it has this concept of modules, okay? So we can import a module, which is, think of it as like an external source code file that somebody has written for us or that we're going to write for ourselves. And those modules are going to give us all kinds of extra functionality. In a little bit, later this afternoon, we're going to take a look at NPM, which is the Node package manager, where all of these modules to do just about anything you can imagine in programming has already been written for us. So if you wanted to make a website that connected to Google search results, right? There is a Google search Node module. You can pull it in, and now with just a few lines of code, you can have search results from Google integrated into your application. Okay. Go ahead.
How is that different? I guess I'm a little confused because I've been trying to work with Chart.js to graphs my roasting app. Is that what you're talking about there? Is that the same thing?
It's a similar concept, right? So Chart.js is like a library that provides functionality to you. What Node has done is take it a step further, which is they created a centralized repository for everyone on the internet so that anytime, the Chart.js authors wanted to make a module available, right? The problem is Chart.js is front-end specific. It's generating charts for the browser to display. All of the modules that we're going to be looking at for Node are going to be things that let us do things in the back end. Connect to a database, make queries, store data, connect to remote APIs. Like stuff that you want to do on the back end, there'll be a Node module for. Stuff for the front end is generally library. There are package managers for front end development as well. Gulp is one of them. Bower is another one. They all are fairly okay. But since we're on the front end, it's just as easy to write a script tag and say script source equals and then put in a link to that package. So, some companies love package managers and they use them heavily, but which one you use is going to depend on which one the company uses. But for Node specifically, when we're doing backend stuff, NPM is pretty much you want to start and stop your search there, and if it doesn't exist in NPM, it most likely doesn't exist. And then if that's the case, you're going to have to write code on your own to make that happen. Okay. So Node modules can be, like the built-ins are the ones that are doing things for the language itself, right? So if we needed to make a server request or we wanted to do JSON.parse, those would be Node modules that are built in and provided to us by Node itself, right? So think of all the default JavaScript stuff you'd want to do. Those are internal, built-in Node modules. Then we can use external Node modules. That's things like npm.org, where we're using some open source package. And then we can also write our own custom Node modules that we don't have to deploy or share with anyone, but it's going to let us write clean code and have an application that understands, hey, for this part of the code, I need this module that I wrote for myself. And then for this part of the code, I'm going to have this other module. So it lets us segregate our source code so that we don't have these 10,000 line long scripts. Okay. Up until now, we've been traditionally focused exclusively on the client-side front-end development. With Node, we're going to be writing kind of this layer, right? The web server and application layer. Right? It's going to let us write code to handle what happens when the browser sends a request to us. Up until now, we've been kind of relying on this nice little plugin that is provided to us by our Visual Studio Code, where it's creating like a little fake server here, and it's serving out all the contents of this file, this folder structure. But what we're going to do with Node from now on is we're not going to rely on this server anymore. We're going to write our own servers so that we can serve all of the content from Node.js by writing our own web server. Now, what you'll traditionally see with Node most of the time is that there will be a web server sitting in front of your application, and that it will pass off requests to Node when something needs to happen. Okay, so traditionally what you'd see is something like Apache, which is going to say, hey, anytime I get a request for a file on the system, like an actual HTML file or a CSS file, just serve that content. But if you're sending a request to like post the form information, right, it's going to say, hey, I'm going to pass that request through to the Node.js application that you're writing in the backend. We are going to, in this class, primarily focus on doing both at the same time. We're going to write our Node scripts to be the web server. But when we get into the deployment phase, right, we're going to use something called Heroku, which is a hosting provider that has a web server, and anytime it gets a request for that matches our product, it's going to pass that request off to our script. Okay, you're going to see both. You're going to see Node being its own server, and you're going to see a web server sitting in front of Node. Both are acceptable architectures, but generally, the dividing line between front end and back end is front end is only on your user's computer. Back end is the stuff that happens somewhere else on the internet. Okay, and then generally, every program we're going to build, for the most part, for your entire career is going to connect to some database, right? So the database is going to be on either a separate server or on its own server in and of itself. So we're going to write JavaScript code with Node.js that connects to a database, fetches information, stores information, and then packages that up as JSON to send it back to the client so that the client can display it. Okay. Any questions about kind of this system architecture? Like, we have to pick big sweeping generalizations like you're mostly going to see this or you sometimes will see that, because just like with everything else, it's entirely up to us how we choose to build our products. We're going to, in this class, try to keep it as simple as possible and just focus on writing good Node.js. We're going to use a server technology called Express, which is its own Node package that gives us a web server into our script. Okay? Go ahead, Josh.
So I guess I'm a little confused on, so you have the web server, that's typically going to be like an Apache server or something like that. And that's going to serve you your actual files, just your general, like kind of like what we've been creating. And then if we're going to post or the user's posting information to the database or to our, I guess it'd be our database, then it's using an application server?
Sometimes, yes.
Okay. So the application in the web server, the application is more like receiving information and updating your internal database. Is that correct?
Yes, most of the time.
Okay.
What we're going to do in this class specifically is we're going to write our scripts, the application server portion of the scripts, to also use an embedded web server. So we're going to write one script that will serve content and handle those requests.
Okay. But then the database is not part of your
Correct.
application
The
server?
database is usually a completely separate server.
Okay.
But Node is such a big language, right? JavaScript is such a big language, and NPM, the package system, is so big that there are modules that let you embed a database right in your code. And what we're going to take a look at, like maybe today or tomorrow, is we can actually, in JavaScript, you remember when we're writing JavaScript on the front end, we don't have any control, we don't have any access to the computer. But in the Node portion of things, we can actually access the file system. We can open files, we can store information directly on the computer that it's running on. So we can write our own database if we wanted to.
Mm-hmm.
So kind of the sky is the limit. You're only limited by your creativity, your imagination. Anything you can do with a computer, you can do with Node. Okay. Karif, did you have a question?
No, I was just going to clarify the reason why it was two different servers. That's all.
Yeah.
Because the web server is facing the front, and so outside traffic goes to the web server in the DMZ.
Yeah.
And your app server is behind, protected, so that.
And what you'll actually see on like most type of deployments or installations is that like the web server is sending out files because it's like Apache has been in use for like 30 years at this point, right? It is super good, super fast at handling thousands of connections and sending files as fast as it can. And what you'll also commonly see is that Apache serves the content to a caching server, something like Cloudflare or someplace like that. So the requests are actually being served through like 3 layers of abstraction. Like if you make a request to the web page for the first time, it's checking a CDN, a content delivery network, to say, do you have this file? And that only the dynamic requests are passed through to your application server when you need to log in or when you need to like get an updated listing of products. The stuff that generally takes the most horsepower from a computing standpoint will be handled by the application server, And one of the things that that Node is extremely good at is it's extremely good at being scalable. And so what you'll generally see in large types of deployments is, you'll write your application code to be express, and you'll deploy it to a service like Lambda from AWS, where it says, I'm going to run this script, and Lambda is going to generate as many of those scripts as it needs to handle the amount of traffic we're currently seeing. So it lets you scale up or scale down super gracefully. That's way out of the scope of this class. We're just going to focus on the writing of the code. But there are all kinds of services that make it really easy to write code, deploy it to a service like Lambda, or use CDNs like Cloudflare, so that you can handle 1 million requests an hour or 100 requests an hour, and it will scale up or down as needed. Right? A service like Spotify, how many people are listening to music at any one time? It could be 1 billion, or it could be as low as 10,000. So they'll use this type of technology to make it so that when everybody's using it, everybody can use it, and when nobody's using it, you don't have all these servers sitting around waiting for waiting with nothing to do. So this is kind of like the lightest weight architecture that you'll ever see, and we're going to do even lighter weight than this, where we're going to have just everything's all in one. We're going to write our code, and we'll deploy it. When you get to your jobs, and each company is going to have a different type of infrastructure. So what you see on your day job is going to be completely different than what you do in your personal life, in this class or on your own side projects. Every company I've ever worked for in the past 20 years has done something different here. So that's part of the fun of it. Right? You get to learn what works, what doesn't work, what's effective and efficient. Go ahead, Josh.
So then we learned about local storage, I think it was last week.
Mm-hmm.
Is that going out the window, or when does local storage really? I know we kind of talked about it, but now that that we're learning this, when would you use local storage?
I would use local storage personally if I was building something that I was I'm going to build this. It's a little tool. Like Olivia was working on that color palette generator, right? That's a perfect thing to use local storage for. It's you can deploy this application. It's a single page. It's just got some HTML, JavaScript, and CSS. You want to let your users be able to store information, but you don't want to create a server. You don't want to pay for a database, right? Local storage is perfect for that, when you don't have to interact with anyone else, right? If you're going to build Facebook or a social network, you have to let the data exist somewhere else so that you can log in on your phone, log in on your computer, send messages to other people. Then you 100% have to have a database. Local storage is great for those rare opportunities where you're building something and you're I don't care about data persistence. I just want to build a cool tool that will store some information. Other things that you might use local storage for in the future is preferences, right? GitHub is maybe a good example of this, right? They have a light mode and a dark mode, right? I don't think they're using local storage for this, but in theory, you can build this beautiful website, give your users an option to say light mode or dark mode. Light mode is the default, but if I pick dark mode, when I come back to the page, reload me into dark mode. Go ahead, Kreef.
So is Node.js industry standard?
Yes.
Okay.
It's not the most popular programming language in the world. It's certainly not the most widely used for web development, but it is in the top 5 for sure. Most likely right there with Java, PHP, Ruby, Python. It's become extremely popular. Specifically for the reason, one of the things that makes Node so powerful is that Node and JavaScript by default is asynchronous, right? So most other programming languages are synchronous. They go line by line, things happen, and you're just kind of waiting for the next thing to happen. Node being asynchronous, it's just running, and when an event happens, when something happens that JavaScript needs to care about, right, Node will do it. It's a very good language for letting us do solve interesting problems. Web development is one of those such things, right? It's you can write Node, and it's going to sit there and wait for a visitor, and then kick off a bunch of work. Okay. It's also used pretty frequently in data science. Some applications where you need to process large amounts of data. Python, it's Python, R, and Node.js. Those are the 3 big ones, because you can quickly prototype. There's a whole bunch of modules that get you there quickly, and so it's used pretty heavily in those applications as well. And then you'll often see it used for, there's a concept in system architecture called microservices, where instead of building one big product, you're going to build a whole bunch of little scripts that do just one thing really well. And so AWS Lambda is infrastructure to run microservices. And so it doesn't even need to run until a request happens, until something says, hey, what is that person's name, or what is that user object? So companies that embrace the microservice type of philosophy, often they'll use Node.js for that type of thing. But Python or some of these other ones, right? Node starts up quickly, it runs fairly efficiently. Like, you're not going to beat C++ in terms of raw speed of how many operations you can process in a second, but for the most part, right, like, it's good enough. It's good enough. All right, so let's take a look at NPM. NPM is, as we kind of mentioned, it's the Node package manager. So if we go to npm.org, oh, that's not the right one. NPM. Why is it taking me to this website? I must have typed it at one point. npmjs.com. npmjs.com. And what's cool is by default it's just like, hey, look at NPM is a cool website, but the real power here is that it's got thousands and thousands of packages in here. So if I was to type in, hey, I want to use MySQL as my database, right? Here is the MySQL Node.js package to let us do that, right? And so I can read the documentation here, and it will show you examples of how to use this code in your application, right? So if you have a database already, I can use this Node package manager. I'm going to say MySQL equals require MySQL, right? The require function. We're going to talk about that here in a minute because that's how we pull in packages. We're going to say require MySQL. It's going to say give me that script. It's kind of like our script tag in the front end. We're saying I need this script to exist in my page and assign it to this variable. Then it's going to say I'm going to create a connection by using that new object that we have here, MySQL, and we're going to call the create connection function with the host name, the username, the password, the database, and then we're going to connect. Right? So this is just one module. We're going to use MySQL in this class for sure. But all kinds of, let's see if there's a weather module. Maybe we can say, yeah, here's an easy way to fetch the weather. Right? So if we wanted to be able to see what the weather's like in our zip code, right? We'd be able to come in here and say, what is the weather.now? Okay? So NPM is the repository for all of these Node packages.
Geolocation?
Yeah. Well, so geolocation is going to be tied to our device, right? So if we wanted to do geolocation, we would probably do that on the front end, on the JavaScript in the client's computer, and then send that request to the back end, right? So if we were going to use this weather module, for example, right, we would use front end geolocation to get this value, where are you at latitude and longitude wise, and then our server would take those coordinates and return back the weather object. And we built one of those in the last class as like one of our examples, like a simple weather looker-upper, right? And now that we have the ability to do things in the back end, this becomes an extremely easy thing to build for us. So this is the Node package manager. I want you guys to get super duper comfortable with this page, right? So when you're looking at a package, right, you got your search results, right? You can see there's a whole bunch of MySQL drivers in here, right? So it's important to start to look at these results. Let's search, for example. Let's just do a generic search, right? So it's important to see, like, hey, what is the version of this, right? They've got some little optimal popularity. You can sort your results by these, right? You got like, this is the most popular, this is highest quality, right? This is open source. Anyone can write a module and submit it to NPM, right? You could write MySQL CBC13. We could write our own MySQL driver and upload it to NPM. It's important when you're picking your modules to pick ones that are well supported, of good quality, and that aren't going to cause your program to break. And this is where you're just going to hopefully get a feel for it over time, because this is a great example, right? This is the official MySQL library. If you're using MySQL, the database, this is their official library for how you do that in Node. And so you can see it's very well documented. You can see they've got hundreds of contributors. They've got issues in here. But it's also important to look like this hasn't changed in 2 years. So maybe this means this library is dead. There's no way of knowing. Generally, what you're going to want to do when you want to implement some kind of package, you want to take a look and see, how many people are downloading this weekly. When was the last time there was a change made, right? All that kind of thing goes into, will this work or not? And this is where it kind of gets into the art of this. It's not a hard science. You're going to want to test a module. Maybe this is where I would go into the Node REPL. I would pull it in, work on it, see if it actually runs, see if it actually does what it says it's going to do, right? Because there's always going to be, here's one this one had a change 10 days ago, right? And this one has almost the same amount of weekly downloads. This was published 10 days ago, right? And it's telling you a little bit of why this module exists. It's a continuation of the original package. They rewrote the parser, they rewrote the API. So this is probably an even better one, right? It follows the same sort of format that the other one did, but it's called MySQL 2, right? So you might want to pick this instead of the other one. It has more features. It's been updated more recently than 2 years ago. Okay. Any questions about NPM? We're going to use the heck out of this all day. When you installed Node, npm, which is another program, was installed in here as well. So if you're in your console and you type npm-v, we're going to tell you what version of npm, the Node package manager, is installed on your computer. Okay. All right. So I'm going to stay in the console for right now. We're going to show you how we use npm. All right. So now that we're working with Node, we want to turn on npm for each and every project that we're going to build. So I'm going to make a new directory. Make their node day 1. Okay. So I'm in node day 1 right now, right? So right now this is an empty project. I don't have any files in here. We have learned that if we want to make this a package in Git, we want to be able to store this for version control. We're going to type git init. Okay. So now I am a Git repository. npm works kind of similarly, right? We need to initialize this to be a Node repository. Okay. If we're going to build any kind of program in Node, we start with an empty folder. This is our first step, right? We're going to initialize a Git repo. Then we're going to say npm init. Okay, and when we do, it's going to ask us some questions. And I'm going to read this off the first time, but you'll get to a point where you're just plowing through here, right? So it's saying, this utility will walk you through creating a package.json file. We'll take a look at that file in a minute. It only covers the most common items and tries to guess sensible defaults. So what it tells you in here is that it's going to prompt you for a series of questions, then it's going to, by default, give you like a default choice. So if I just hit enter through here, those default choices will be picked. So it's saying, what is the name of our package, right? The name of our package is the same as like these names, right? So whatever we make a package, if I try to call this MySQL 2, I could run that program locally. I can call my package MySQL 2, but I could then never use the MySQL 2 module if I needed to. So we want these names to be kind of unique. Generally, when you're making your package for the first time, it's going to be like the name of your company or the name of your product. For you, Karif, yours might be like Classroom Time Tracker is the name of your project, and for Josh, yours might be Roast Log. Okay, and maybe there is a Roast Log in here. Let's look. Roast Log. Okay, good. No Roast Log. So Roast Log would be a valid package name if you ever wanted to publish this as a thing. All right, so I'm gonna hit enter here. Node day 1. By default, it's taking whatever the folder name is. Okay, but I'm gonna hit enter here. Now, it's saying, what version is this code? And it's prompting you with the default is 1.0.0. Let's talk really quickly about versioning, because this is, you're going to see this time and time again. This is called semantic versioning, right? Where it's broken up into 3 places. Now, this is just one of many type of versioning schemes, right? I'm sure you guys have seen, like, maybe at some point you've seen like a Windows version where it's like 36.14.2010, right? You can, any company can come up with any kind of versioning scheme they want, but Node by default, and this entire ecosystem, uses this type of versioning system. The first number denotes the major version, right? So some major thing has happened, right? Version 1 is the first one we build. Version 2 is the new one that completely changes everything, right? With all kinds of new features. In between major versions, is minor versions. Minor versions is things like, I added a new feature, but the program is essentially the same, right? So version 1.1 is just version 1 with something extra. And then the final number is patches, right? So every time you make a change, maybe it goes up by 1, where you're saying like, I fixed a bug that was causing a reference error. Now this only really matters for if you're deploying it as a module or if you're working on a team with a bunch of company and you actually care about tracking the version. But by default, when we're running npm, it realizes that this could be a module someone is using online, right? So, maybe we're writing open source. We want to tell them what version we're doing. And this will become important in a little bit when we look at how this package manager lets us pull in modules and run some code. Okay, so by default, you can just leave 1.0.0 here. If you wanted to put in a description, you could do so in here. You can say like, this is my first Node app, right? Whatever you want. If you're writing something open source, you probably want to, put in some, MySQL client for Node.js with performance, with a focus on performance. Like 1-line description of what is this module doing, okay? Hit enter there. It's going to say, what is the entry point for this application? Okay, and by default, it's going to pick index.js for us. If there was another JS file in this program, if I had app.js in this folder when I called npm init, it would say, oh, okay, well, I know this folder was empty, but there's another program in here. I'm going to use app.js or whatever file was in there already. But index.js is kind of like the norm when you're building a package or when you're building a module. You're just going to call it index.js. Okay, and then if you have a test command, we're going to talk about testing later, you could type that in here, but we're going to leave it blank for now until we get to testing. If you had a remote Git repository, you could put that in here. Now, if we were to go the other way, if we were to create this on GitHub, then git clone this folder, this repository would be automatically filled in our .git. If we had a remote origin set up in this Git repo that we set up right here, that would be sucked in already. But we didn't. So if we want to add our Git repository in the future, we would have to choose that here. And the reason that they care about this remote repository is because they kind of make the assumption that you're going to put this on npm, and so that links in right here. So that if you were deploying this, you said, hey, I built this really cool app or this really cool module, I want to share it with the world. If you put something in that repository thing, it's going to link you right to here so that other people can contribute and make your product make your package better. But we don't have one yet. And then if you wanted to have any keywords in here, this would help npm let people search you and find, so I could put in like MySQL, API, something, right? Any keywords I want. But we're going to leave this blank. And then author, you can type in your full name, you can type in whatever you want in here. Right? It's just going to be how this is referenced and associated to you. And then if there's a license, if you wanted it to be GPL or MIT, when we were talking about open source licenses in the first week, right, you would type this in here. If you just put ISC, it just means this is copyright me. I wrote it. It's not open source. Okay. And then it's going to ask you, is this okay? All right. If we put yes, we're good. Now, when I ls in this directory now, you'll notice that there is a package.json file. This file is everything for us. It controls how our program is run. It controls our dependencies. It controls if we have any testing environments or test suites, which we'll cover later. But this file is really just this JSON object. You'll notice this is JSON that describes what our program is, right? So if any of that information we put in was incorrect, we can come in here and edit this file, and now our program knows a little bit more. If we change our license in the future, we can change that here. If we ever had a test suite in place, we put this in the scripts test. Okay. The cool thing is, right? We were loading Node before. Let's cp index.js, right? Oh, /. Right. So I put this index.js file in here, right? This was the one that we had. Node index.js. Okay. That was that code we wrote before. With npm now, because we have in our package JSON that the main entry point is index.js, right? That tells us that npm now knows enough about our program that it could run it for us. So I think it's like npm run. I'd have to put it in as a thing. We'll talk about scripts and turning this on, but essentially when all these people are building these packages like MySQL, it's letting them know that like this is the main source code file of this repository that we're bringing in. So when we start installing other packages, it's being added to our package JSON. All of that source code is being pulled down from the internet and shoved in a file on our computer or on our server so that when we write our code, it knows what files to bring in. That's why it's called a package manager. Now, the reason the versioning is important is that like if you were to run an npm update, that command is going to look at all the modules you're using and check to see if there's any versions that have changed, right? If you were using MySQL 2 version 4 point whatever, what are we at here? 2.3.2. If they come out with 2.4, running npm update will let us bring in 2.4. So now our code can stay up to date without us doing anything. Okay. Any questions about the npm package manager or go ahead.
So it updates automatically, or it just lets us know what we need to update?
No, so it doesn't. Nothing happens automatically. But what it does is it gives us tools like npm update to go and check for updates and to run to make sure we always stay up to date. And so what you'll generally see is that when you're working for companies, this will be a part of the deployment process. They'll look for updates to see, hey, we always want to run version 3 point whatever. But every time there's a minor update or a patch or a bug fix, they'll deploy your version of whatever your application you're writing is, and it will also run npm update to go and check and get that newest version, so that all of your packages and modules can stay up to date. Any questions about that? Okay. Probably time for a break. When we come back, we're gonna install some packages. Play with how do we get this into our code. Cool. So it's 5:52. Let's come back at 6:10. 6:10. You have a long break. Go for a walk, stretch, get some drinks. Recording. Cool. All right. So we have our package here, right? Right now it has a package.json and an index.js. So let's say I need to install a Node module. I want to use some open source package that exists on the internet, right? So let's use Express, because we're going to use that a lot over this course. You don't have to pay too much attention to the actual module itself. We're just going to kind of show off this process, how it works, right? So I know I'm going to build some kind of web application. I know I'm going to need Express. I look at this, maybe I read the documentation. I say, yeah, that looks like what I need. Okay, so from my console, let's actually bring this up in bring it up in a real folder. What do we call it? Node. Great. All right. So I'm in my index, and I know I want to be able to run these lines of code, right? Because I need this to be a web server. So let's pull up in a terminal here. Great. Let's make this a little bit bigger so everybody can see it. And I'm going to do this, right? So I know that I want to be able to paste this lines of code into my app and have it be available, right? So I'm just going to replace all that with this, okay? And then their example formatting is terrible, so I'm going to put in semicolons so that I like myself. All right, I am going to be calling Express and say, hey, require Express. Now, if I was to run this right now and I say node index.js, it's going to say a whole bunch of errors. Error cannot find module Express. Okay? The way that we install modules is extremely easy with Node. We say npm install Express, the name of the package we want to install. And when I type this, it's going to do some stuff. It's going to install all the packages that it needs, and it's saying, hey, Express version 4.17.1 has been added. And you'll actually notice that if you look at this Node modules folder, right, it created a Node modules folder where it stores all of those libraries that this module needs. And Express adds 50 total packages, because Express is a server that needs all kinds of stuff: array flatten, body parser, cookies, cookie signature, right? All kinds of stuff that Express requires, right? If we were to look at the source code for Express, it's going to, inside of itself, have code that says, hey, I need this module. Let's see if we can find it. Express, right? So let's look at Express. Express has a package JSON that tells you that it needs all of these dependencies, right? So all of these different packages have been installed by Express. So that's kind of the power of NPM and the power of this package manager. We can write one line of code, right? Express went through and built this beautiful framework for us to use that for us is 6 lines of code, but behind the scenes, Express has, thousands of lines of code that require hundreds and 50 separate dependencies. All of these packages are kind of structured the same way. If we were to look at just pick any one of them, let's look at accepts, for example. Right? Accepts has a package JSON, and this might have dependencies. It requires MIME types and negotiator. And so if we were to look in here, right, MIME types and negotiator were installed because this module has required it. Okay. You'll also notice that because I said install Express, now you'll notice that our package JSON has a dependencies thing as well. And it says this application, my node package, node day 1, requires Express. So this package JSON file is telling our server in the future, right? We're doing all of our development here on our local computer. And when we get ready to deploy this to a server, this package JSON will be included inside of our version control. So when we check this out with GitHub or with Git, we run npm install. It's going to install any dependency that's listed in our package JSON, and then it's going to go into Express and say, what dependencies do you have, and install all of those dependencies. So everything that is needed to run this program will be included in here. But now I've got this. Now that I've got Express installed, if I was to go to my terminal and I now say node index.js, okay, now this code is running, right? So Express is a simple web server. We said, hey, we're going to create a route on the slash, and when a request comes in, it's going to send hello world, and it's also saying, hey, we're going to listen on port 3000. So now, just like what I had before when we were clicking the go live button, now we don't have to do that. Because if I go to localhost port 3000, it's going to serve back hello world to us. All from these 8 lines of code. Now, obviously, this is a very simplistic example, but this is how we install packages and dependencies so that our project can make use of all the things on NPM. Right? Everything that we could need to use, they're always going to be brought in with the word require. That's how it actually becomes available to us inside of the JavaScript. Right? We put it inside of a variable called express, and then we created an app variable that is the value of the return of the express function, and then we can define our routes. Any code we need to write, we can do inside of our script now because we've got all that power from the module. Okay. Now, if for some reason, let's turn off this server. If we said, oh, we didn't want Express after all, right? I'm in the package. I can do npm uninstall Express, and let's actually do this in this terminal so you can see. All right. So here's the file package.json. If I do npm uninstall Express, right, it's going to uninstall that program, and now you see that this dependencies field has disappeared. Now, if we were to try and run our program again, node index.js, and tell us that same error. Express could not find module Express. So whenever you're working with node packages, node modules, if you ever see this type of error, it's telling you exactly what to do, right? You either have to install this manually, npm install Express, or what's more likely a scenario is that you've pulled this down from GitHub and that this module was already in here. Let's, I forgot what version it was. Cool. I'm just going to copy this whole thing, right? And I'm going to say npm uninstall Express. So all these files should be gone, right? So let's delete this folder. Here we go. rm-rf node modules. Okay, so let's just imagine I just pulled down this source code from version control. It has a package JSON It has a package JSON file in it, and it's got the dependencies that this requires. Okay. If I was to try and run this node index.js, it's going to tell us that error. Hey, it's missing this module. Okay. But generally, your first step, you'll notice I have no node modules folder here. Generally, your first step is just to run npm install without specifying the module you're going to do. When you put in npm install and you don't include a module, it's going to read through the list of dependencies here and install each and every one that's required for this app. Right, so if I hit this, you should see a folder pop up in here, yep, with all of those modules that we had before. Okay, and this is why, if we go to GitHub very quickly, GitHub, let's make a new repository. Node day 1. I'm going to make it public. Right. This is why we add a .getignore, because we're putting in the node getignore. If we type in node here, right? This node getignore is including, hey, ignore any log file, ignore any of these debugging stuff, but more importantly, ignore anything in the node modules folder. We don't want to include the source code of all these different packages. We want to just upload our source code. The package JSON file will tell the future computer that we're going to run this on what modules it needs to install. We don't want to include all of these different things in our version control. So let's hook this up here. Copy. And I'm going to simply go in here and say git remote add origin. Okay. Cool. And then let's commit our. Well, let's do a git pull first. Git pull. Right, so that's going to pull in our git pull origin main. Right, so that's going to pull in that node, that gitignore file, and you'll see I'm in the source control tab here. All of these files that it thinks it cares about, as soon as I pull in this gitignore file, those should all disappear. Right? If you look at, we have a gitignore in here now. Yep, and all of these have disappeared. So now it's just index.js, package lock, and package.json. Now, package lock is just a different copy of the version. Like, it's a bigger, more expanded version of that package.json. You don't ever have to go in here and change things in here. This is generated automatically by npm. So, but it will need to be there. It will create it at some point when you're playing around with npm. Okay. So we're going to check these into version control just to show this off. Initial entry. Okay. I'm going to push this. Yep. Good. So now if we reload over here, we can see that we've got index.json or index.js, and we have package.json that describes, hey, this needs Express to run. Okay, if we were to delete this folder entirely, let's do that here. cd dot. I'm going to close this. Okay. rm-rf node day1. Okay, so that folder no longer exists on this computer. Generally, the workflow is like we have this existing on GitHub. I'm going to copy this. You know, what do we type in here? We say git clone, and then the URL to that Git repository. It's cloning it into node day one. If you go to cd node day one, right, you'll notice none of those node modules are in there. If I was to run this now, node index.js, it's going to give us that cannot find module express error. But we would run npm install, which will install all of those dependencies. Okay, and now if we do an ls, we'll see we do indeed have a node modules package. Anything that you type in with npm install, any module that we put in here, if we put in MySQL2, for example, right, is going to install the module on the computer, and more importantly, if we pull this back up as a, where are we at here? And more importantly, it's going to include that in here as a dependency, so that as we're adding more modules, you'll notice it's saying, hey, I want to use version 2.3.2 of MySQL2. Now, what does this little caret signal here mean? This little up arrow. There's a couple of things that Node has given us through this package manager that let us specify what to do about these versions. We were talking earlier about, like, will this auto update our stuff for us? And the answer is no. But when we run npm update, right, new terminal, npm update, it's going to check on npm to see if the version I have specified in here is up to date. And this up arrow, this caret, which is Shift 6 on our keyboards, tell us what to do. So the up arrow is saying, give me the latest minor version. The latest minor version. And if you remember from here, the minor version is this, right? So if I had long header. If I had 2.3.1 in here, right? It's going to give me as high as it can to get up to whatever the biggest version for here is. So if 2.3.2 is out, then when I run npm update, it's going to try and pull that down, right? Npm update. And I think I have to, let's delete this. Delete. Okay. If I was to run npm install here, it should try to give us MySQL2 version 2.3.2, right? MySQL2. If we pull up this package JSON, yeah, we're at 2.3.2. So we're saying my application requires at least 2.3.1, but if 2.3.2 comes out, grab that as well. So when we run npm update, as these packages are coming out, we'll get those little bug fixes all the time. But that's the default behavior. When I type npm install, you'll notice it's putting this caret in for here and for Express. So it's saying, I'm going to run 4.17, And every single time you make a bug fix and this number goes up, I want that to be brought in for me. If we put in the tilde, it's just saying, hey, just give me the latest patch version. Or star is give me the latest version, right? If we put in a star in there. So if I said, I don't care if it's 4.17.1. If you come out with version 5, I want that too. Now the problem is, like we mentioned, in semantic versioning, right? Generally, the major version over here changes features, right? So your source code might actually break if you put an asterisk. So it's just something to be aware of. If you're working on a project that's not like super critical, it's just a hobby, put in an asterisk, and you'll be ready to go. But when you're relying on packages and modules from somebody on the internet, there's no guarantee that they're not going to, a great example is if Express for some reason comes in and says, hey, instead of app.listen, the new function is app.start server. Okay, now your code would break and all your customers would be angry. So be very careful with what you put in here. Okay. Any questions about dependencies like this? Okay. Now, there's another kind of cool thing, right? So here, we're local developers, right? So we're writing the code on our computers. We know it's going to be deployed to our server somewhere. That's great. But maybe we need some special modules that help us become better developers, help us examine things. Maybe we need some logging library that like tracks events and things. We can also say npm install. I'm going to put in nodemon. If you do --save -dev, it's going to save it as a development dependency only. And what that means, you're going to see this pop up. We'll see dev dependencies here as soon as this finishes installing. Great. So now it's installed a development dependency. That means that this package exists on my computer, but when I deploy this to a server, it will not be installed. Okay? So nodemon is a really cool, and we're going to use this pretty frequently in this class. Nodemon lets us run our code and watch for changes to our code, and when there is a change that is found in our source code, it will automatically reload the program. So if I was to change a line of code in here, right, we've got our hello world. Is this still running? No, we have it turned off. Let's do this. So if I run node index.js here, right, I have this server running in the background. If I was to make a change, I want this to say hello world Eric, right? I save that code. This still says hello world because this program is still running. Right? I would have to turn this off and turn it back on to see those changes. Okay. What nodemon lets us do is that we can come in here and write a script, right? So all of these scripts that come in here, right? There's one that says test, says there's no test specified, is that we can tell npm to run our program using a different program, right? So we can come in here and say, let's just call this dev, and we will say nodemon index.js, right? Because we just installed the nodemon package. If I close this program and I say npm run dev, and I'm going to run this script, which is going to call nodemon index.js, nodemon is going to watch my code, and it's now taken over the console, right? Saying starting node index.js. If I change a line of code in here, hello world Steve, right? It restarts that program, and now I can reload. So I can make changes as I'm going, and a node package is watching our source code, kind of how our editor was doing that for us before. I use nodemon all the time because this saves me a bunch of close the program, reopen the program nonsense. This is just the way to go. If I was to make an error in here, right, I'm going to save this, is going to be an error. It's going to say the app crashed, waiting for the file to change before restarting. And it's showing you the error, right? I did not put my close parenthesis and my semicolon at the end. It's telling you there's a syntax error, you're missing a parenthesis. But as soon as I save this file, right, now it's restarted. Now it's back up and running. So it's a really useful tool. This is just the tip of the iceberg of all the cool things you can do with Node package manager and all these like mixing and matching modules, right? Software developers have built all of these modules. If we were to go here to npm and type in nodemon, right? Some person somewhere was frustrated with, having to restart his applications all the time, and so they built this package, this module for us that lets us watch our code for changes. Right? This is the beauty of open source. This is just the tip of the iceberg. There are thousands and thousands and thousands of packages on npm that let us do just about anything we can ever hope to do. We were talking about Google earlier, right? If you wanted to embed Google search results in your page, right? Into your product, right? Here, I can require Google, tell how many results per page, and then, run a Google search. All from the comfort of our source code. All right, let's install that real quick. That sounds fun. So I'm going to close this, and I'm going to say npm install Google. Okay. Cool. So now the Google package is in here. How do we use this? We say, require Google. Let's just play with this for a little bit here. Let's turn off the web server that we got going. So we're saying var Google equals require Google. We want 25 results per page. Next counter, right? So it's saying Google Node.js best practices, and when those results come back, it's going to loop through those results and log them to our console. Right? So if I run this now, and I say node index.js, we should see a whole bunch of Google search results coming here, except it looks like it did not work. So this is a perfect example, right? This Google, was last published 5 years ago. Google has changed a bunch since then. So this is one of those, like, someone published this library, and it no longer works. Okay, so if I actually needed Google results in here, I might have to hunt around a little bit, looking for a real module. Anyone have any questions about installing? Right, so now we know this module doesn't work. Let's uninstall it. Uninstall Google. Gone. And it's no longer in here. If, for whatever reason, right, nodemon is a great example, where I use this all the time on every program I'm ever working, right, for the most part. I can do npm install nodemon, and I can put in -g. That's going to install it globally on my computer. So any package I create will have this available. Okay? This would install it on my entire computer. Okay. Any questions about installing, uninstalling, updating packages? You guys get it? Cool.
Yes.
It's very important to get very comfortable living inside the documentation on this page. This is like the start and end point for interacting with these packages. Some are really easy, right? This is MySQL's, this is an actual database connection, right? So it can do a ton of stuff, right? Tons of examples in here of making queries, and we're going to learn all about this when we learn about databases. But if I'm using this, right, almost all of my answers are going to probably be included in this documentation. They did a very good job documenting all of these examples. But it's very important to get very comfortable in this interface, in this website, because they're going to tell you, if I need to go see the homepage, if I need to see the repository, how frequently is this being used? When was the last update? How many outstanding, these pull requests is coming right from GitHub, right? So there might be, if you actually come across a bug with one of these programs, right, they might have this already ready to go, teed up, that you could, in theory, come in here and say, hey, this needs to be fixed. This affects me as well, right? You can comment on these and say, I also have this problem. Okay. We kind of briefly talked about scripts. So inside of our package JSON, right, if we want npm to run our program for us, right, we want it to run, when we're on dev, we can say npm run, and then a key that is in this object, right? So if I said npm run test right now, it's going to say error, no test specified, right? That error code. It's going to run whatever script is inside of here. So what you'll often see is that when you're working on real programs, you know, you might actually have a production, and it might do something like, you know, what's an example? There's like a PagerDuty type program or something that like says, I'm going to run this code that you put in here, and if there's an error, I'm going to send a text message to the engineering team so that they know that like 2 a.m. your server's crashed, right? So you can put in any type of script, right? As long as that script runs validly, right? So in our example up here, nodemon index.js, right? We can tell our code to always run npm whatever, and npm run production would do something different. Okay? So you can specify any type of scripts in here. When we learn about testing a little bit later this week, we write automated tests in here. You know, this might run some other program that is running through a test suite, and it's saying, hey, this module expects to have this function, did it return true or false, so that we can write code and make sure that when we're continuing to develop on it, that it doesn't break, that when we make changes and we go from version 1 to version 2, like nothing is broken. You'll see that if we come into these node modules, for example, here, let's see if we can find one. CD node modules. Maybe one of these is good. Let's look at the array flatten. Let's cat package JSON. Do they have a test in here? Yeah, they have a test. So they're running some kind of test suite called Istanbul, and they're saying, hey, I want full coverage, and they're running against some specification. So the developers of this have built some tests for them to let them test to see if this is working. Right? And if we were to come in here and say npm run test. All right, so we don't have Istanbul installed, but if we wanted to, we could say npm install Istanbul save dev, right? Now we can run the tests. Oh, so that, you know, Istanbul is probably some test suite that they built for themselves. Right, so we, you know, if we actually cared about going to find whatever test program they were using, we can go hunt that down. Maybe there's a better example somewhere else. Let's see. Array flatten maybe. Yeah, they're running Istanbul as well. Let's see if we can find this out. Istanbul test program. I don't know. Okay. So they want us to install this NYC package. Let's try that. NYC. Oh man, this has a whole bunch of packages, huh? And then let's try running npm run test in here. What if we change this to yeah. Let's see. Oop. Package JSON. Let's change this to NYC instead of Istanbul. Let's see what this does. NYC. Whatever they're doing with Istanbul is not working for us. They probably have some different version of this package installed on their local computers. But we can explore the open source of what everyone else is doing. And later this week, we're going to use Mocha to write our own test suites so that we can make sure that the code we're writing will continue to work forever. And so you can do that by specifying a script to run when someone calls npm run, so that you can, you know, do all kinds of different things. You know, at some companies they'll use npm for like setting up a database for the first time. When you first run it, it's going to connect to some database, install a bunch of fake data, so that you can make sure that your program is going to work in like a realistic environment. Any questions about scripts? Okay, there's also a very cool NPM function called NPM audit, right? So we've got all of these dependencies in here, right? And we've said, hey, this is version 4.17.1, but don't go to version 5 or don't go to version 6 or whatever, right? So our code is going to get kind of locked in time, right? We know our code is going to work, it's going to run forever, but maybe a year down the line, right? Maybe MySQL is up to version 3, but we haven't moved to version 3 because we didn't know if anything had changed. There's a program called NPM audit where if we run it, it's going to check all of those NPM modules that are installed, and it's going to look for vulnerabilities, right? So actual exploits or things that can cause, some nefarious, third-party hacker from Russia or someplace can exploit your code and go in there and test it out. So obviously, we're using the latest and greatest stuff here. We just installed these packages. There's no exploits found, but NPM audit is a good tool to let you just see, hey, do you know of any problems with the modules I'm using? So this is really more of a senior administrator task, or somebody that's on your team that's responsible for security. But it's always a good idea to just know that this is available, right? If you're a single developer, you're working on a project just for yourself, and you don't maybe touch it very often. Maybe you're building your roast log app, and you get it working, and then you don't come back for a year. Right? NPM audit will tell you if something in any of the modules you're using has a vulnerability and what to do about it. Okay. All right, I think that's a pretty good stopping point for today. Are there any questions about Node, NPM, packages, anything we want to go over? We're going to keep playing with packages and modules for the rest of the class. So this is just a high-level overview, and we need to get everybody installed and on the same page. Go ahead, Kareef.
Do you mind going over the scripts one more time?
Yeah. Scripts is extremely easy. It's just us going in here and saying, hey, I'm going to create a word, test, dev, production, whatever we want, and then what the value of that key is it's going to run that as a command, right? So in this example, test, for example, if I run npm run test, it's going to run this script, right? And so in this example, it says echo error, no test specified, and it exits, right? So if I run this, it exits, no test specified. Okay. If I run npm run dev, it's going to run the program nodemon index.js. So it's just a way for us, because this is our package JSON, when we're working on a team or when we're working for ourselves, like this lets us put stuff in here that make our lives a little easier, right? If this project was more complex than index.js, right? We had more than one file. Maybe we have, a calculator app, or we had some kind of database checker or something, right? We could run check db, and it would run like node db checker.js, right? So we can specify any types of things we want to have available to us.
Okay.
Yep, good question. But 99% of the time when I'm in here messing with scripts, the only thing I'm doing is I'm almost right off the bat, especially when I'm working with Express or one of these types of things we'll be doing in this class, I'm going to go in there and put a dev version and then use nodemon and then run the file so that nodemon will reload my program every time I make a change. This is a huge quality of life improvement. Because if I did not do this, right, node index.js, every time I make a change to this code, I have to come in here, do Control-C, which will close the program, press up arrow, and run it again. Right? Seems like an awful waste of time. Any questions?
So you just have was it nodemon in the scripts?
Mm-hmm.
Okay.
And then I run it with npm run dev. So whatever you put after npm run has to match some script in here. If we did npm run home, whatever, it's going to say missing script home. It's telling you that it doesn't know what's in here. these scripts are for us. That's as developers, we get to choose what we put in here. You know, I picked dev because I want to type 3 letters, but you know, this could have been npm run development, npm run development. It's going to run that script. But most importantly, perhaps, is that package JSON, package lock.json, those have all this information, and it's checked into version control. So as we're building more complex applications, as we're adding more modules and packages to our programs, the description of how to install and get the program up and running is included in version control. This is like configuration as code, right? We're saying like, everything I need to know about how to install this program is included as a part of the source code, so that I don't have to hunt around for like, what version of packages did I run in here? It's gonna tell us. And if I needed to get documentation of why isn't this working, I can go straight to npm and look up npmjs.com. I can look up how does MySQL 2 work, and then read through the documentation. Cool. What do you guys want to do? You want to keep working on our group project? You want to keep making some progress on our test, our quiz test maker? Okay.
Good with me.
All right. Olivia started us today, finishing off that thing. Who would like to start and be in the hot seat for building the form, the quiz builder? It's going to be a form that generates JSON.
I can do it.
All right, Josh, take it away. Let me stop the recording.